So now I want to talk a little bit about adding and subtracting fractions and mixed numbers. And previously we've talked about adding and subtracting fractions with common denominators. But in this video I want to mainly focus on using uncommon denominators. So these are denominators that are not the same, meaning uncommon, so not the same. And we're going to use least common multiples to figure out our common denominators. And sometimes we refer to, when we're using the least common multiple, oftentimes people will change that last letter to least common denominators. So the D is for denominators. Okay, this one here is for multiples. So when we're just comparing numbers to find a common multiple, you're more likely to see LCM. But when we're actually doing a fraction problem, addition or subtraction, and you want to find the lowest common or the least common multiple, then we would rephrase that and say least common denominator. They both pretty much mean the same thing though. Okay, let's go through some examples, and I'm going to start off with just adding and subtracting, or let's see, we're going to do adding first. The first problem will not be with mixed numbers. These are just proper fractions, and we'll find the least common denominator, solve it, and then we'll work with a mixed number problem. And then we'll do the same for subtraction. Okay, so the first example, we've got 5/6 plus 4/9. 5/6 plus 4/9. Now, because these denominators are not the same, the numerators cannot do the operation. We can't just say 5 plus 4 and then, the issue is that these are broken up differently when compared to the 4/9. So we need to reorganize both of these fractions so that they're organized similarly, and then we can have the numerators perform the operation. Now, to find the least common denominator, we're basically going to think about what common multiple or denominator the 6 and the 9 would have. And you might want to first think, well, does 6 go into 9? Because sometimes that's a real easy way to find the common denominator. In this case, however, 6 does not evenly go into 9. So, you want to just think of the multiples of 6 and 9. And, I know that's going to be a multiple of 9. So 18 is going to be my least common denominator for this problem. Now, a good way to write this out is to rewrite it in a vertical fashion so that we can kind of work outward and do some changes to our fraction. So I'll show you what I'm thinking here. So if we take 5/6, and then underneath it I'm going to put plus 4/9. Okay, now what we want to do is kind of extend the fraction lines out a little bit, and we're going to be multiplying to the numerator and denominator for each fraction, and I'll show you what I mean here. So what we're doing is we're converting to 18ths. We know that's going to be our new denominator, so that's what we're shooting for. So 6 times what will give you 18? Well, 6 times 3 will give you 18. And because we're multiplying by 3, we need to do the same in the numerator. And so 5 times 3 will give you 15. Now again, we want to look to the denominator and think, how many times are we going to multiply 9 to get to 18? And if you're thinking of 2, you are correct. 9 times 2 is 18. Therefore, 4 times 2 will give you your numerator, which will be 8. So really what we're doing is something that we've done a while back is we're creating fractions that are equivalent, but they're in higher terms, okay? So the numbers are larger, but these fractions are going to be equivalent with the original ones. Now remember, we're adding, so the numerators can now do its job. 15 plus 8, that's going to give you 23. And then the denominator is going to remain 18. Now notice this is an improper fraction, and like previously, we want to convert that to a mixed number. So 18 goes, excuse me, 18 goes into 23 one whole time, and then we need to basically take the remainder. And if you look here, you can kind of do a little subtraction here. 13 take away 8 is 5, and so it's going to be 5/18. So 1 and 5/18 is going to be your answer. Let's go ahead and look at a mixed number example in which the denominators are not the same. So in this example, we're going to have 2 3/4. And I'll go ahead and write it down below. Here we have 1 7/10. And again, we're going to add. So like before, we're going to find the least common denominator. And we have 4 and 10. And now I know my least common denominator has to end in 0. So if you think of 4 times 5 will give you 20. It looks like that's going to be the case, but let's go ahead and write down our multiples in case you're still kind of working this out, and that's okay. And sure enough, I get to 20. 10 times 2 is also going to give me 20. So we're now going to convert these to 20ths. So I'm going to write that. I'll extend this out and write that here. And for now, I'm going to just ignore those whole numbers. Or if you'd like, you can just go ahead and bring them over here. We're not converting to improper fractions when we're adding and subtracting. Right now, we're just going to move them over and just focus on changing the denominators for these parts of these mixed numbers. So 10 times what will give you 20? Well, 10 times 2 will give you 20. Therefore, 7 times 2 will give you 14. Here we have 4 times what will give you 20? Well, 4 times 5 will give you 20. Therefore, 3 times 5 will give you 15. Now we've created equivalent fractions. They just have a common denominator now. Now we can add, and with mixed numbers, it really doesn't matter if you add your whole numbers first and then your fractions, or your fractions and then your whole numbers. So I'm going to start with the fractions first. That's going to give me 29/20, and 2 plus 1 is going to give me 3. Now notice this portion of the fraction, or the mixed number, is improper. So like the last problem, we want to convert that improper fraction to a mixed number, and then that whole number that we get from this improper fraction, we're then going to add to the 3. Okay? And so I'll break it out for you. So here I'll just rewrite the 3. Now 20 goes into 29 one whole time, so I'm going to add 1, and then what's left over is 9/20. So this here, 1 and 9/20, is the same thing as 29/20. But now I want to kind of condense it to make it one answer. 3 plus 1 is 4, and 9/20. And notice we cannot reduce that any further. So that's my answer. Okay, let's continue on. We're going to do a little bit of subtraction now. And get a different pen. So in this problem, example 3, we have 5/6, and we're going to subtract from that 3/4. Okay? 5/6 minus 3/4. Now 4 does not go into 6, so I need to think of some multiples. 4, 8, 12, 16, and let me try some 6's. 6, 12, you know, I don't need to go any further. 12 is going to be my least common denominator. Okay, and if you, so that's going to be my new denominator. So let me extend some lines here, and then we will make some new fractions that are equivalent, but instead of 6 or 4ths, they're going to be broken up into 12ths. So my new denominator is in 12ths. 4 times what gives me 12? 4 times 3. Therefore, 3 times 3 will give me 9. 6 times what gives you 12? 6 times 2. Therefore, 5 times 2, and that's going to give you 10. So 5/6 is equivalent to 10/12. 3/4 is equivalent to 9/12. Now we can subtract, and remember, we're only subtracting the numerators. 10 minus 9 gives me 1, and then the denominator is 12. I have 1/12 left over. Now let's try a mixed number example. Hopefully you're kind of getting the hang of these problems. After this problem, I'm going to show you some subtraction problems in which you have to borrow from the whole number in either a whole number or a mixed number. And they're a little bit harder, but not too terribly. So in this case, we're going to have 4 3/4 minus 1 1/3, and you know, I accidentally wrote it out this way, but sometimes you read it like this, and in that case, just rewrite it, just so you give yourself enough room. And extend that out, and then we're subtracting. Okay? So, you know, 3 does not go into 4 evenly, so we need to find a common multiple or a common denominator, and I'm going to go 3, 6, 9, 12. I think it's going to be 12. Let me check. 4, 8, 12. Yep, that's the lowest one. So 4 times what will give you 12? Well, 3. And so 3 times 3 will give you 9. 3 times 4 will give me 12, and so 1 times 4 will give me 4. And then I'm going to go ahead and squeeze in these whole numbers. And remember, we're going to subtract. So 9 take away 4 will give you 5. The denominator is 12ths. And then 4 take away 1 will give you 3. It doesn't look like I can reduce in this situation. Okay, let's do a little bit of borrowing. And this is slightly harder, but not terribly. Let's say we have 2, and we're going to subtract from that 1/3. So what we want to do is take this 2 and create a mixed number. So if I take away 1, I'm left with 1, and I want to make a fraction that is going to be equivalent to 1. Now, remember, we've talked about these fractions previously. The other thing I want to make note is that since we want it to be thirds, because we're going to then subtract a third, you want the denominator to be a 3. So if we want this fraction here to equal 1, the numerator has to be the same as the denominator. So 1 3/3 is the same thing as 2. I'm just kind of deconstructing that 2 and making it look differently. It's now 1 3/3. Now I can take away 1/3. And you could have written this horizontally or vertically, but it looks like I can do it easily this way. I'll show you it vertically as well. So 1 take away 0. There's no whole number here, so that's really a 0. So that's going to give me 1. And then 3 take away 1 will give me 2/3. And so again, if you wanted to write that out vertically, we could have done that easily. We could have gone 2 minus 1/3. And then we're going to rewrite that as that's going to be 1 3/3. And then I'll just bring this over as well, 1/3. And then we can go 1 2/3. So we get the same answer. This is kind of how it would look, vertically. Let me do another example, just so we get some more practice. These are a little tricky. Let's say we have 10, and we're going to subtract 7 and 11/17. So I'll go ahead and rewrite that vertically down below. So we're going to have 10 minus 7 and 11/17. Okay. Now again, there's no fraction here that I can take away the 11/17 from. So I need to rewrite this. I'm going to take 1 away, so that gives me 9. And I want my denominator to be in 17ths, so that means my numerator is also going to be in 17ths. So I'm going to just rewrite this underneath 7 and 11/17. And remember, we're subtracting. So 17 take away 11 is going to be 6/17. 9 take away 7 will give me 2. 2 6/17. Now let's do one more of these borrowing problems. This one is actually a mixed number. So let's say we have 1 1/4, and we want to take away 3/4. Now notice we don't have to find a common denominator like the last one, but I want to, because I'm trying to make it easy and to show you how we can borrow even though we have a fraction here. So I'll go ahead and rewrite it. So 1 1/4 minus 3/4. Now notice, I cannot take 3 from 1. If I do, I'm going to get a negative number, and I really don't want to deal with negative numbers right now. So if I take away a 1, okay, that will leave me a 0. How can I write that 1? I could write it as 4/4. Now, that 4/4 is going to take the place of that 1, but I want to add it to the 1/4 because I don't want to omit this part. This is part of the problem. It's the whole thing. So what I'm going to get is 5/4. So 4/4 plus 1/4 is 5/4. And yes, that's improper, but basically what we've done is we've made the numerator larger, so now we can take away 3/4. So now 5 take away 3 is 2/4, and of course we can reduce to 1/2. Let's do one more like this, because you might think, well, if I just change it to an improper fraction, that will be the best thing. It worked out this way because my whole number in this mixed number was a 1. But what if it's a larger number? Then that's not necessarily the best way to go about it. So let's go ahead and do another problem. I'll just make one up. Let's say we have 5 1/3, and we're going to subtract from that, and I'll do it down here. Let's say we're going to go 2 2/3. So 5 1/3 take away 2 2/3. Our denominators are the same, so we don't have to worry about finding a common denominator. But I cannot take 2 from 1 or else I'm going to get a negative. So I'm going to take 1 away from that 5 and rewrite it as 4. And because I'm working in thirds, I want to write 3/3. So 4 3/3 is going to be the same as that 5. But notice I still need to include the 1/3 in there. So I'm going to add 1/3. And that's going to give me 4 4/3. So this is equal to 5. Okay. And then I need to include this part because that was part of my original problem. It wasn't just 5, it was 5 1/3. And so that's why I'm adding here. I get 4 4/3. Now I can move this all the way over here and I get 2 2/3. I'm not changing that one. Now I'm just going to subtract. 4 take away 2 is 2, and I'm working in thirds. 4 take away 2 is 2, so 2 2/3. And that is going to be the result. Well, like always, if you have questions, ask in class and we'll do some more examples.